Okay, so now we'll talk about limits of a sequence, or limits of sequences. Sorry. All right, so you can see that this sequence, an equals 1 over n, as n gets bigger, this thing is getting smaller. It looks like let's see, so as n gets big, goes to infinity, 1 over n gets small, right? Goes to 0. Let's see, if you put in 100, right, you'd have 1/100. That's pretty small. So what does the graph look like? There's our x-axis. Let's see, at 1, let's say we're 1, we're at 1. 2, we're at a half. Let's see, go to half there. 3, we're at a third. 4, really close there. So you can see that as n approaches infinity and gets big, 1 over n gets small. So here we'd say the limit as n approaches infinity of an, otherwise known as 1 over n, equals 0. Let's look at an equals n plus 4 over n plus 1. At 1, we're at 2.5. At 2, we're at 2. 3, 1.75. 4, 1.6. 5, 1.5. All right, let's pick up the pace here. I'm going to jump to 10. 10, we got 1.27. Let's jump to 20. 20, 1.142. 100, 1.02. And at 1,000, we're at 1.003. So here, as n gets big, an approaches a specific number. You can start to see what that is. It's going to be approaching 1. So remember, y is going to be an, in this case, which is n plus 4 over n plus 1. Okay, so we're approaching 1. Let's say, here we are at 1. And at 1, we're at 2.5. So let's see, that's about 1. That's about 1 there. We're at 2.5. Something like that. At 2, we're at 2. 0.75. Getting closer and closer to, or converging on to 1. Okay, so here we'd say that the limit as n approaches infinity of an, otherwise known as n plus 4 over n plus 1, equals 1. Okay, now let's look at an equals cosine. Okay, now look what's happening here. As n gets big, an doesn't really go anywhere, right? Sometimes it's negative, sometimes it's positive. So in this case, there is no limit. The limit does not exist. It bounces around. Now we know cosine is between positive 1 and negative 1. My bad. Negative 1 and 1. I was upside down. And so this thing is sometimes it's positive, sometimes it's negative for a while. Then it's positive again, and it's negative again, then it's positive. There's no real pattern. So it doesn't narrow in on anything like the other two examples. It doesn't narrow in on anything, so the limit does not exist.